All right, here we go, guys. We are looking at 6.4, Triangle Similarity today. We had all these methods back in the middle of the semester, I guess I would say. We were learning how to prove two triangles congruent. We had the side, angle, side, angle, angle, side, hypotenuse, leg. Do you remember those theorems? Side, side, side.
Yes.
Okay,
Yep.
so we have some theorems today. These are the three. There's only three, which is kind of nice, that prove that we have similar triangles. So the first one we're going to talk about is angle-angle similarity. It says if two corresponding angles are congruent, then the triangles are similar. So if we have two angles that are congruent, then we know we have similar triangles. And when we have similar triangles, we can set up little proportion sides. You can look at the corresponding sides and make a little fraction equals to fraction, okay? So here we have a triangle ABC and triangle DEF. We want to determine if the examples below are similar by angle-angle similarity. If yes, write the similarity statement. So is triangle ABC similar to triangle DEF?
Yes.
Yes, because angle A is congruent to angle D, and angle C is congruent to angle F. Why is it that we only need two angles?
Because the base is gonna equal the B. Sounded better in my head.
Yeah, well,
Like the base, like.
well, are you talking about AC, the length of AC?
Yeah.
Well, that's very different than DF, so I don't understand.
Whatever.
Yeah, very good, Natalie. So what Natalie said was, how many degrees are in a triangle? 180. Okay. So can I figure out angle B?
Sure.
Yeah, absolutely. 180 minus 75 minus 31. This must be 74. And what's the other angle E? Also 70. By default, it must also be 74. All right, because we have a fixed number of degrees to start with. So we only need to show that two angles are congruent because the third is always going to be congruent if two already are. All right, so does that make sense to you?
Wait, why don't you spike it as angle, angle? Angle, angle, angle.
Because it's redundant, because the third one must be the same. So mathematicians are fundamentally lazy. If two is all we need, and the third must be by default, then we're not going to say angle, 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 because that's just one more character, and we would rather be lazy. Okay? All right, so the similarity statement. Triangle, if I write ACB, would be similar to triangle what?
DEF?
Nope, D starts.
DFE?
DFE. Okay. All right, look at number 2. Number 2. Are the triangles similar?
Yeah.
Why? Vertical angles. Yes, we have a pair of vertical angles are congruent. So we do have another pair of congruent angles. Great. So these are similar. So they are similar. I'm going to give it the little squiggle. All right, so triangle, if I say VXW is similar to triangle what?
CXY?
Nope.
No, YXZ.
YXZ, yes, because I started with the single arc mark, then went to the double, then went nothing. So VXW, YXZ. All right, super. So they are all similar by angle-angle similarity. I'm going to write that down. By angle-angle similarity. Okay, so we also have side-side-side similarity. If all corresponding sides are proportional, then the triangles are similar. If the sides are proportional, are the sides going to be congruent? No, they're proportional. All the sides have to be the same ratio. So I want to compare. Right off the bat, these two triangles appear to be in the same orientation. So I'm going to write a ratio. 3 would correspond to which side? 6. Yeah, so 3 over 6. And I want to know, is it the same as? Give me another pair of corresponding sides.
5 and 10.
Okay, I heard 4 and 8, so that's 4 over 8, and I want to know if that's the same as, and then I also heard 5 over 10. 5 over 10. Are all those ratios the same?
Yes.
Yeah, they all equal 1/2, don't they? So they are all in proportion, and then they are similar by side, side, side similarity. We can say triangle QPR. QPR is similar to triangle what? TSU. Good. Side, side, side similarity. So again, these aren't showing congruence. They're showing that the ratio of the corresponding sides are the same. All right. Looking at number 4, again, I assume they're oriented the same way. So give me some pairs of corresponding sides. 30 over 24. What's another pair? What's another pair of corresponding sides? Yeah, 32 over 25. And the third pair? 35 over 28. Good. Now, are all those the same? I have no idea. I'm going to check on my calculator. 30 divided by 24, that's 1.25. 32 divided by 25, oh, that's 1.28. So they are not equal to each other. And because they are not the same, all of these were equal. This one is not similar. Okay. All right, the last one we have is no, just you.
Oh, come on.
Just you. Just you. All right, the last one we have is side angle side similarity. If two corresponding sides, so we want corresponding sides, are proportional and the included angle are congruent. Included has to be between the sides. And so you can see here we have two side lengths, and where those sides come together, that's the included angle, the angle between those two sides. So they are, here we have a side and an angle and a side. And so what we want to check here is, are the corresponding sides proportional? What are my corresponding sides? What corresponds to 8? 6, all right. So 8 over 6, and then what's the other pair of corresponding sides? 20 over 15, so 20 over 15. Are those congruent or equal, rather? I don't know. 8 over 6 is 1.333, and 20 over 15 is 1. Okay, great. So they are proportional. They are equal to each other. They both equal 1.3 repeating. Okay, so we know that they're proportional, and we have angles that are marked congruent. So these are similar by side angle side similarity. So I would say triangle, I'm going to go JKL is similar to triangle what? Good, MNP. All right, and then number 6 is a really good question here. I have some sides. These are overlapping triangles. I have a small triangle. I'm just maybe going to highlight this small triangle in pink here. Maybe you can see it a little bit better. And then I got the big guy in blue. So I've got the big triangle in blue on the outside there. Maybe that's helpful. And again, we're looking for side angle side. So looking at my pink triangle, what side does 15 correspond to? 25, yeah. So we've got this sort of upper left side here, DA, and then that's going to correspond to the big side, AB. So that would be 15 over 25. And I want to compare it to what's another pair of corresponding sides? 12 and 21. 12 over 21. Again, I need to see if they are the same ratio, so I'm going to divide them because that's what the fraction tells me to do. And 12 over 21. Ooh, are they congruent? No, they are not equal. They are not proportional. All right, which means that they aren't going to be similar. Let me ask you, though, do they have a pair of congruent angles? Yeah, what's the pair of congruent angles? Angle A, yeah, absolutely. A is in both triangles. They share that common angle. So they did have the included angle there. These are not similar. Okay. All right, but interesting discussion. So let's go through and do a little bit of checking here. Let me turn that. Okay. All right. Determine whether the triangles are similar by angle-angle similarity. If yes, write a similarity statement. I like these first two. Why do I like these first two a lot?
Because
Parallel lines. Parallel lines every time. We have parallel lines. What off the bat do you know from this picture, number one?
vertical angles are congruent.
Vertical angles are congruent. Great. Let's mark those angles congruent. Vertical angles are congruent. Vertical angles are congruent. I love writing that down. Never want to forget. Now we also have parallel lines. So what are we looking for on parallel lines? That sort of Z shape. Yeah. And we've got a couple of them, really. I could go parallel line, transversal, parallel line. And do you see the Z sort of shape? If you imagine and squint and tilt your head. So here we have angle D is congruent to angle F. But I could also go the other way. I could go up, and then I've got a transversal, and then hit my parallel line again. So really, the third angles are also congruent by parallel lines. So if parallel, alternate, interior angles are congruent. So those are our two justifications if we were writing a proof. So do we have a pair of congruent angles?
Yes.
Yes. So are we similar?
Yes.
Yes. So triangle, it says write a similarity statement. If I say triangle EDC, oops daisy, I meant to write a similar, is similar to triangle what? No.
EFG.
EFG. Yeah, I went EDC. So single arc mark, double arc mark. So I'm going to do the same thing. EFG. EFG. All right. Number two, another great question. Do they have any congruent angles?
Yes.
Which angle?
G and D. I mean, D and F.
I'm on number two. Where are you?
Oh, I was still on number one.
L. Both we have a small triangle and we have a large triangle. All right. They both share angle L. Both triangles use angle L. That's the reflexive. All right. If you want to write that down, reflexive angle. They both have angle L. What else? What other angles are congruent? We have parallel lines, remember?
M and N, because the second triangle also shares the same transversal as the big one?
So, I mean, I do have parallel lines right here, all right? And they're being cut by this transversal, one of them, that's one transversal over there. So I have parallel line and a parallel line. What angles are congruent? Bella, I think you said it. I said N. Yeah, so those are also congruent. So if I make this transversal pink, there you go, you can imagine there's that transversal. So N and P are congruent because they're in that sort of lower left position. So if parallel, corresponding angles are congruent. We have corresponding angles. I was looking at angle, this sort of M and this Q angle down here with the dots that I put on. Those are also corresponding angles. All right, so we have, they are similar by angle similarity. So triangle, I'm going to go triangle QLP. QLP is similar to which triangle? MLN. Triangle QLP is similar to triangle MLN. All right, let's look at number 3. Are they similar? Yes. Yes. Let's see. Triangle EYS. EYS is similar to triangle what? How do I know that they're similar? How do we know they're? Ah, okay. So 180 minus my 39 minus the 90 degrees, I get a 51 degree angle there. And so this one, if I subtract 51 and 90, I must have a 39 degree angle. So yes, we did subtract in the brains or calculators, whatever. All right, so if I write EYS, what's my other triangle similarity? HCW. Yep. All right, number 4. Are they similar? How do you know? They don't look it? Yeah. So, you know, in geometry, we're never allowed to assume the drawing is to scale. You can only go by your knowledge and markings that we know. So what do we need to do? We don't have side lengths. I'm not going to do proportions.
Fraction 68 over 63.
Those are not side lengths. They're angle measures. They're degrees. They're angle measures.
Just the numbers right corresponding. They don't equal the same. So one angle is 68.
So 68 matches. Okay, but can I figure out what angle B is? Couldn't B also be 63? Maybe. Do I need to figure that out?
Yeah.
Yeah? Okay. So 180 minus the 68 minus the 54, is 58 degrees. If I figure out the third angle over here, 180 minus 68 minus 63, I get 49 degrees. So these only have one angle in common. These are not similar. But you do need to figure out the other angle measures. Just like this one, we had one 90-degree angle, one angle matched, and then the two didn't appear to match, but when you figured out the third angle, they do. All right, so you gotta pay attention. Okay, let's look at number 5. What is this little angle B that I've marked here with a dot? Can you figure out the measure there? What is it? No. 22. How come it's not 25? I know why you thought it might be 25. we don't have parallel line markings, so we can't assume that the lines are parallel. And so we have a triangle here. If we just subtract from 180, we can get the angle measure correct. Okay. What's angle M? Yeah, 180 minus 67 minus 25. If we want angle M there, we have the big triangle that we can subtract the angles from, and we get 88. All right. Do we have similar triangles here? Angle similarity? No, not similar. Okay. What about number 6? Vertical angles. Very good. So yes, these are similar. All right, I'm not going to write the similarity statement. I think you got that. Okay, determine whether the triangles are similar by side, side, side. So we want to determine it by side, side, side similarity. Now what are we comparing? Proportions, side lengths, corresponding sides. Okay. Well, this is a challenge. Are these oriented the same way? No, they are not. How do you think we can figure out the corresponding sides, potentially? Like, they're not oriented. Should I, like, redraw the triangle?
Yeah.
We could. Yeah, maybe I want to do a little, what do I need? I need to maybe spin around this baby a little bit. Spin it around. Or really just flip down the corner, but it does, not too sure. Yeah, so I think that this is supposed to be the 9, and then this was the 13.5 on the bottom, and then 20.25 on the long side there. So this is N, this is K, and this is R. So you can sort of do a little spin around thing. But I'm also going to say that shouldn't the longest side be proportional with the longest side of the triangle? Like, it'd have to be that way. So you can just look and say, hey, the longest side here of each triangle would have to be proportional. So let's see, 20.25 over 31.5. Is it proportional to what and what? So if the longest over the longest, then we can also compare the shortest and the shortest, absolutely. So maybe 9 and 14. So I would do 9 over 14. And then last we have 13.5 over 21. And again, I need to see if they're the same. So 20.25 over 31.5, 9 over 14, and 13.5 over 21. Are they the same? Yeah, they are. They all equal some crazy, crazy decimal there. So yes, they are similar by side, side, side similarity. So this would be triangle. I'm going to go KNR. KNR is similar to triangle DES. Yeah, DES. Good. All right, I really like number 8 here. Again, we have overlapping triangles, which can be really, really challenging. So you need to think about the whole triangle. We have a small triangle, and we're comparing it to the big triangle. Is this 6 part of the big triangle? Is it a side length on the big triangle? It's not. It's not the whole side length. It's just a part. Okay. All right. Yeah, is that what you meant? Okay, good. So again, I'm going to compare. If I look at this side WX, which is the small side here on the small triangle, 15 compares to what? Yes, 21 is the whole side length, 15 plus the 6. So 21. And then I'm going to compare that to 20. And what's the big corresponding side? 28. The whole side length is 28. Yes. So 20 over 28. And then last we have what over what? 30 over 42. 30 over 42. So we're comparing the whole side length, not just little baby parts. All right, not little baby pieces. So again, I need to compare 15 over 21 and 20 over 28 and 30 over 42. Yes, they all are congruent. So they are similar. So I'm going to say triangle WXV is similar to triangle WYU. All right. Any questions so far? Make sure you figure out the whole side lengths there. All right. How are you feeling with this? Let's look at number 11.
You can spin it.
Okay, we can spin it a little bit. So this triangle, I'm going to just sort of move that X to the side so that the X is over here. All right, so I can spin it a little bit. So I get a 13 and a 5. So that's X, and then this would be Z and Y. Okay, so I spun that little baby triangle a little bit. What do we need to do here? Can I figure out if we're using side, side, side similarity? Do I have enough information? I'm missing a third set of sides, right?
Yeah.
But it is a right triangle. Can I do something to figure out the hypotenuse? The Pythagorean theorem, yes. A squared plus B squared must equal C squared. So I can do 9 squared plus 21.6 squared must equal my hypotenuse squared. 9 squared plus 21.6 squared is 547.56. What do I have to do to figure out the length of the hypotenuse? Square root both sides. I'm going to do the square root of my answer, and I get my hypotenuse for the big triangle is 23.4. So this equals 23.4. Can I do something to figure out this side? What can I do for here? Same thing, similar. I can do, let's see, 5 squared plus B squared equals my hypotenuse squared. So 5 squared plus B squared equals my 13 squared. Let's see, that's 25 plus B squared equals 169. And then we can minus 25. So we get B squared equals 144, which means square root B equals 12. Oh, 5, 12, 13. That's called a Pythagorean triple. Nice one. Nice one. Comes up a lot. There's another 3, 4, 5. All right. So now we have our third sets of sides. So now we can compare our sides. And I'm just going to do short with short. So 5 over 9. And I can do 12 over 21.6. And long with long, so 13 over 23.4. And again, I have to know, are they all the same ratio? Because they sure look weird, don't they? 5 over 9, 12 over 21.6, and 13 over 23.4. Are they all the same? Yeah, they sure are. So yes, they are similar by side, side, side similarity. All right. Let's just do a couple more here. Number 13, we're looking for, are they similar by side, angle, side? And remember, the angle has to be between the two sides. Really important here. So on number 13, what do we know in addition to what's given? Vertical angles are congruent. Beautiful. And it is between the two sides. We have a side, and then we have our angle, and then we have a side. And the same is repeated over here. We have a side and an angle and a side. So potentially we're good. How do we need to set up our proportion here? Because these triangles are a little bit screwy. Like, should I write 6 over 48? No. Why can't I do that? So if I start with 6, what side's going to correspond in the other triangle? 24. How did you figure? It switches, it does, but I went with short and short. Okay, got to use the smaller length. So 6 over 24, and then 12 over 48. So the longer side over the longer side. And that reduces to 1/4, and that reduces to 1/4. So they are equal. By side, angle, side, similarity. They've got it. What about number 14? We do know that vertical angles are congruent. Do we know any other angles are congruent? Is that an included angle?
40 and 25.
So if you did, you could write the proportion 40 over 25. So we could write that proportion. But is our angle that we know congruent, is that in between the two side lengths? No. We would need this angle right here and this angle over here to be congruent. So the angles here is not included, not an included angle. And so we can't use side angle side because that angle that we know is congruent is not in between our two sides. We'd need this one. We need this one. All right. So we have to be very careful when we use side angle side that we get the right angles. All right. Last one, number 15. Number 15. What do we have in that picture? Parallel lines. All right, so which angles are going to be congruent? Yeah, so here M and this side of the right side of P there are congruent. Why? Corresponding, good. Corresponding angles are congruent, all right, and they are in between our two side measures that they've given us. So now, since we do have an included angle, I want to look at my side lengths. So 36 compares with 36 over 22, and I'm going to compare that to 54 over 33. And again, those are really weird numbers, so I'm just going to use my calculator and see that they divide to the same crazy value. And those are the same. Look at that crazy number. All right, so these are, they do have side, angle, side similarity. Okay, do you have questions for me? All right.